Imagine a moon so large it dwarfs a planet. That's Ganymede for you. It orbits the colossal gas giant, Jupiter. But Ganymede is a giant in its own right. It is the largest moon in our entire solar system. To give you some cosmic perspective, it's even bigger than the planet Mercury. If Ganymede were to break free from Jupiter's gravitational embrace and orbit the Sun on its own, we would undoubtedly call it a planet. It is a captured world, a king among moons, holding court in the majestic Jovian system, a place of wonder and immense scale. Ganymede is not alone in its dance around Jupiter. It belongs to a prestigious group of 4 moons known as the Galilean moons. Galileo Galilei first spotted them in 1610 with his simple telescope. This discovery changed everything. It showed us that not everything in the heavens revolved around Earth. The other 3 moons are Io, a volcanic world covered in sulfur; Europa, a smooth ice ball hiding a vast ocean; and Callisto, a heavily cratered and ancient body. Each is a unique world, but Ganymede, the behemoth, stands out not just for its size, but for its complexity. The discovery of these moons was a pivotal moment in human history. It was a direct challenge to the long-held belief that Earth was the center of all motion. Suddenly, here were 4 points of light, 4 tiny stars that clearly orbited Jupiter. It was a profound revelation, a cosmic truth revealed through a small lens. Ganymede and its siblings helped us redraw our map of the universe. They were the first stepping stones on a journey to understanding our true place in the cosmos, not as the center of it all, but as part of a much grander, more intricate dance. So when we look up at Jupiter, we're not just seeing one world, we're seeing a miniature solar system. And at the heart of this system's moons is Ganymede. It's more than just a satellite, it's a destination, a place of immense scientific interest. Its sheer size is an invitation to explore. It beckons us to come closer, to uncover the secrets it holds. This moon, bigger than a planet, represents a frontier of knowledge, a place where our understanding of how worlds form and evolve can be expanded in ways we are only just beginning to imagine. What lies beneath Ganymede's frozen surface? It's not just a simple ball of ice and rock. Scientists believe Ganymede has a complex, layered structure, much like Earth. Deep inside, it is thought to have a molten iron core. This swirling liquid metal heart is the key to one of Ganymede's most remarkable features, which we will explore later. This active core generates heat and energy, making Ganymede a dynamic and active world, not just a cold, dead piece of rock. It's a sign of a complex geological life hidden from our view. Surrounding this metallic core is a rocky mantle, but the most exciting layer lies above that. Evidence strongly suggests that Ganymede hides a vast salty ocean deep beneath its icy shell. This isn't just a small pocket of water, it's a global ocean, possibly containing more water than all of Earth's oceans combined. This subsurface sea is sandwiched between layers of ice, a hidden realm of liquid water preserved by the pressure and heat from the moon's interior. The possibility of a liquid water ocean makes Ganymede a prime target in the search for life beyond Earth. The outermost layer is a thick crust of ice, hundreds of kilometers deep. This icy shell acts as a protective shield for the ocean below, insulating it from the cold vacuum of space. The existence of this structure, a metallic core, a rocky mantle, a liquid ocean, and an ice crust, makes Ganymede a differentiated world. It means its materials have separated based on density, a sign of a complex and active geological history. This moon isn't just a big ice cube, it's a fully fledged world with its own internal engine, a place of profound complexity. Think about that for a moment. A moon with its own layers, its own internal heat, and its own hidden ocean. Ganymede challenges our very definition of what a moon can be. It's a celestial body that shares more in common with planets like Earth or Mars than with our own moon. This layered structure is a roadmap to its past and a guide to its present. It tells a story of formation, of heat and pressure, and of the potential for environments that could, just possibly, harbor the conditions for life. When we look at images of Ganymede, we see a surface that tells a story of a dramatic past. The moon's face is not uniform. It's a patchwork of two distinct types of terrain. First, there are the dark regions. These areas are old, ancient even. They are saturated with craters, scars from billions of years of impacts from asteroids and comets. These dark, cratered plains are thought to be the original crust of Ganymede. They are a time capsule, preserving a record of the chaotic early days of our solar system, a violent history written across its surface. Then, there are the bright regions. These areas are younger and cover about 2/3 of the moon. They are marked by a complex network of grooves and ridges, stretching for thousands of kilometers across the surface. These grooved terrains look as though the surface was pulled apart and reformed. Scientists believe these features were created by tectonic activity, where the icy crust was stretched and fractured. Watery slush from the ocean below may have erupted onto the surface, flooding older craters and creating this newer, brighter, and smoother terrain. This dramatic difference in terrain suggests a geologically active past. Ganymede wasn't always a quiet, frozen world. There was a time when its internal heat was great enough to drive massive geological processes, reshaping its entire surface. One of the most striking pieces of evidence for its violent history is a series of faint, concentric rings, the ghost of a colossal impact. This feature, known as the Valhalla Impact Basin, suggests that a massive object once slammed into Ganymede, sending shockwaves rippling through its icy crust like a stone dropped in a pond. And there's another surprise. Ganymede has an atmosphere. It's incredibly thin, a tenuous exosphere, but it's there. And what's it made of? Oxygen. This oxygen isn't produced by life as it is on Earth. Instead, it's created when charged particles from Jupiter's powerful magnetic field bombard the moon's icy surface. These particles split the water ice, H2O, into hydrogen and oxygen. The lighter hydrogen escapes into space, while the heavier oxygen lingers, forming a very thin atmospheric layer. It's a different kind of breathing, a planetary exhalation into the void. Here is where Ganymede truly sets itself apart. It is the only moon in our solar system known to have its own magnetic field. This is an extraordinary feature. Planets like Earth have magnetic fields generated by their molten iron cores. But for a moon to have one is unheard of, until Ganymede. This intrinsic magnetic field is a direct consequence of its hot, swirling, liquid iron core. It creates a small magnetosphere, a bubble of magnetic influence around the moon. A moon with its own personal force field. This personal magnetosphere is completely embedded within the gargantuan magnetic field of Jupiter. The result is a complex and dynamic interaction. Jupiter's magnetic field lines race past Ganymede, but the moon's own field carves out a protective cavity. This interaction is not a quiet one. It's an energetic dance that generates incredible phenomena. As Jupiter's field lines connect and reconnect with Ganymede's, they channel charged particles toward the moon's poles, creating something beautiful and familiar, auroras. Yes, Ganymede has its own northern and southern lights. The Hubble Space Telescope has captured images of these faint, shimmering ribbons of light glowing in ultraviolet wavelengths at its poles. These auroras are a visual testament to the powerful magnetic wrestling match happening between the giant planet and its giant moon. They are a constant reminder that Ganymede is not just a passive body, but an active participant in the physics of its environment. The auroras rock back and forth, following the sway of Jupiter's magnetic field, a celestial light show in a far-off place. Ganymede, the giant moon, is a world of superlatives. It is bigger than a planet, has a hidden ocean with more water than Earth, and boasts its own magnetic field that generates auroras. It is a place of immense scientific fascination, a complex world that challenges our ideas about where the ingredients for life might be found. Each new discovery, from its layered interior to its glowing auroras, invites us to look closer. Ganymede is not just one of Jupiter's many moons. It is a destination in its own right, a cosmic treasure waiting for us to explore.